section 3.6 is all about mathematical models and building functions to represent these models. So it's going to be, this section is really just me doing a bunch of examples so we can kind of get the hang of building these mathematical models. So let's let P equals x comma y be a point on the graph of y equals x squared minus 8. What if I want to express the distance from P to the origin as a function? So friendly reminder that our distance formula is the square root of x1 minus x2 squared plus y1 minus y2 squared. And the origin is 0, 0. So I want to know the distance from this point on my graph to the origin. So I already know that I've got distance equals the square root of x1 minus 0 squared plus y1 minus 0 squared. The only problem is I don't know what y is. Y is our dependent variable. So I'm going to substitute y with x squared minus 8. So this gives me d is the square root of x squared plus y squared, and I'm going to substitute in x squared plus 8 squared for y. I'm then going to go ahead and FOIL this out, so I get the distance is the square root of x squared plus x to the fourth minus 8x squared minus 8x squared plus 64. And I combine like terms, so I get the distance from a point on our graph of y equals x squared minus 8 to the origin is x to the fourth minus 15x squared plus 64. Remember, we always want to get everything in terms of x. X is what we know the value. X is our independent variable. So it's what we want our equations in terms of. Okay, so let's say I have a wire that's 10 meters long. This is 10 meters. And it's going to be cut into two pieces. One piece is going to be shaped as a square and the other as a circle. And I want to express the total area enclosed by the pieces of wire as a function of the length x of the side of the square. So this is going to be 4x, and this is, so if I divide this, and this one's being made into a square, and this one's being made into a circle, this is 4x, and the whole length is going to be 10, so this is going to be 10 minus 4x. So the length of one piece is 4x, and the length of the other piece has to be 10 minus 4x. Let's talk about what I know. The area of a square is x squared, and the area of a circle is 2 pi r squared. Okay? I also know that the circumference of a circle is 2 pi r. Now, this isn't 2, sorry, this is just pi r squared. The circumference of a circle is 2 pi r. I don't know the circumference exactly, but I know that this piece of wire, this piece of wire that's length 10x minus 4x, this is what's going to become a circle. So that's my circumference. So I have 10 minus 4x equals 2 pi r. I know what 2 pi is, so I'm going to solve for r. So I have 10 minus 4x over 2 pi equals r. So now my new area of this circle, I'm going to substitute in for r. So my area of the circle is pi times 10 minus 4x over 2 pi squared. I need to go ahead and square this. So my area of my circle is pi times my denominator squared, so that's going to be 2 squared pi squared, and then the top I have to FOIL out, so that's going to become 100 minus 8x plus 16x squared. So I have that one of these pi's is going to cancel, so I'm left with 100 minus 8x plus 16x squared over 4 pi. So the area enclosed by the piece of wire and as a function of the length x of the side of the square is going to be, my total area will be x squared, because that's the equation for a square, plus 100 minus 8x plus 16x squared over 4 pi. Oh, but I could factor out a power of 4, couldn't I? So this is really going to be x squared plus 25 minus 2x plus 4x squared over pi. Now it's asking what is my domain. So what values can x take on? Well, at most, if I had a circle with it, if I didn't cut it into 2 pieces, right, I could have x equals 0, but x can't be any smaller than 10 divided by 4 if this was just going to be a square. So I get 2.5. All right, next. A wire is 10 meters long and it's going to be cut into 2 pieces. Man, that sounds familiar, except this time one piece is going to be an equilateral triangle and the other will be a circle. So I've got this 10 meter long piece. I'm going to cut it into 2 pieces, and one piece is going to be an equilateral triangle. Now remember, an equilateral triangle, the length of each side is the same. So this is going to form a triangle with side length x, and what's left over is 10 minus 3x, and we're going to use this to make our circle. Remember, the area of a circle is pi r squared. Their circumference is 2 pi r. So to solve for the radius, I know that circumference over 2 pi equals r. Okay, so my area for the circle is going to be area equals pi times r squared, and my r in this case, my circumference is 10 minus 3x over 2 pi. I go ahead and square this. We're still just finding the area of the circle. I get 100 minus 60x plus 9 x squared over 4 pi squared. One of these pi's is going to cancel. So I have 100 minus 60x plus 9x squared over 4 pi. This is the area of my circle. Now, we know that the equation for the area of a triangle is 1/2 base times height, and we're working with an equilateral triangle of side length x. So let's go ahead and open up another page. If I have my area is 1/2 base times height of my equilateral triangle, well, I know that my base is x, each side is x, but I need to figure out my height. Well, luckily for me, if I cut this down the middle, I can figure out my height using the Pythagorean theorem. A squared plus b squared equals c squared. So if it's equilateral, I'm cutting right down the middle. The length on this side is 1/2 x. So I have 1/2 x squared plus my height squared, this is going to be my height, plus my hypotenuse squared, that's x squared. So I've got 1/4 x squared plus h squared equals x squared. If I subtract 1/4 x squared from both sides, I get that h squared equals 3/4 x squared, and I can take the square root of both sides. So I get h equals the square root of 3 over 2x. So now I have that area equals 1/2 my base, which is x, times my height, which is the square root of 3 over 2 times x. So I have x times x gives me x squared, and 1/2 times the square root of 3 over 2 gives me the square root of 3 over 4. So this is the equation for the area of my triangle. So the area for our triangle and our circle together, we're going to have to add them to the two areas we found for our final answer. So the area of this entire equation would be the area of my triangle plus the area of this circle. The domain, if I had a triangle that took if I had all circle would be 0, and then if I had a triangle it would be 10 divided by 3 would be the cap, but just less than, not less than or equal to. All right, the next problem I'm going to have us working on, and also the last problem, is about a box. So an open box with a square base is to be formed from a piece of cardboard that is 24 by 24 inches. This will be done by cutting a square out of each corner and turning the sides up. What we want to do is express the volume of the box as a function of length x of the side of which is the side of the square cut from each corner. Okay, so my volume typically is length times width times height. In this case, my height, when I fold everything up, is just going to be x. I know that whatever's left over is 24 minus 2x, because we're taking away 2x. Each of these little sides would be 24 minus 2x. And that's the length from here to here, and here to here, here to here, and here to here. So that's going to be my length and my width. So I've got x times 24 minus 2x squared times x. So next I want to know what would the volume be if a 3-inch square is cut off. So volume equals 24 minus 2 times 3 squared times 3. My volume equals 24 minus 6, which is 18 squared times 3. So my volume would equal 972. We're in inches, so it'd be inches cubed. And therein lies Chapter 3.